Okay, good afternoon, ladies and gentlemen. So I'm doing our lesson for today on the computer because there's some functionality that I want to show you guys to do during the assessment for today. All right. Excuse me. So our objective for today is that students will be able to identify linear and exponential relationships on the table. Okay, so we're going to do a bit of review today along with learning some new concepts. All right. So just a really quick review, right? We spent a whole unit talking about linear relationships. So just a refresher, a linear relationship is a relationship that when graphed has all of your points ending up in a straight line, right? Now, something that we noticed in the past when we studied this is that linear relationships grow by addition, right? And specifically, we said that thing that you're constantly adding over and over again, we refer to as a constant rate of change, okay? Now, exponential relationships are different, but they're actually a little similar in the same way, right? So technically an exponential relationship occurs when you have a value that's increasing in proportion to its current value, okay? So basically what that just means is that exponential relationships grow through multiplication, right? So the example where we saw with the pennies on the chessboard, the example we saw where you're cutting up slips of paper, remember we said that it kept doubling over and over again. So to go from one item to the next, we ended up multiplying by 2 every time, right? And that 2 that we had to keep multiplying is something that we refer to as the growth factor, okay? So the growth factor in an exponential relationship is kind of like the constant rate of change or the unit rate in a linear relationship, okay? They're related. So just to kind of give you a table to look at it side by side, linear relationship, work through addition, exponential relationships work through multiplication. A linear relationship, we refer to it as a constant rate of change or a unit rate. For an exponential relationship, we refer to it as a growth factor, right? And one more thing that just is going to end up coming up more this unit. When we talk about linear relationships, we're talking about graphs that look like a straight line. When we look at exponential relationships, we actually have graphs that end up being curved upward like this line here, right? If you saw the graph for the first 2 investigations, you should have seen a graph that was somewhat curved like this, right? Now, that brings me to a meme that I find funny. I usually put it up in my classroom when we're studying this unit. It says, what you want, fam? Let me get that y equals mx plus b, say no more. And we got that hairline right there, right? But this is actually incorrect because y equals mx plus b would be a straight line. So his barber must not have been paying attention in math class. He actually gave him something that looks closer to an exponential relationship instead of a linear relationship, okay? So make sure that when you go to the barber, they know their math, otherwise they might mess up your haircut, all right? Life lesson. So what we're gonna be focusing on today is just trying to look at some tables because we're gonna be working with a lot of tables this unit and trying to figure out which ones are exponential, which ones are linear, right? So I've got some instructions on what you're gonna be doing here. So first thing is you're gonna look at the set of tables below. You're gonna try to decide by looking at the table if it's linear or if it's exponential. I say to color the appropriate box green. I'm gonna explain what I mean there. And then figure out, is it a growth factor? Is it a constant rate of change? Color that box green as well. And then you're gonna write what the actual growth factor or constant rate of change is. Okay, it sounds like a lot, but it's actually not. So let me walk you through 2 examples, okay? So I have a table here. Let's focus right on the left-hand side. So I have my x values here. I have my y values here. So first trying to figure out if this is linear or if this is exponential, right? Easy way to decide if it's linear is to check, am I constantly adding the same number over and over again? And if I see from here, right, -1 to 1, maybe you're not so good with negative numbers. So let's look from 1 to 3. I can say, okay, to go from here to here, that's going to be +2. Same thing, to go from 3 to 5, that's going to end up being +2. So adding 2 going down, so that has to be linear. So what you're going to do is you're going to make the box that says linear green. That's going to indicate to me that you're saying this one is linear, right? Now, if it's linear, that means that I'm talking about a constant rate of change and not a growth factor. So you're gonna make this one here green as well, right? And now we're gonna write down in this case here that our constant rate of change was actually 2 because we are adding 2 as we move down the right-hand side of the table, okay? Remember, constant rate of change, same thing as slope. Technically, we did rise over run. So our rise comes from this side, our run comes from this side, right? For every example for today, well, 9 out of 10 examples, you're increasing by 1 here. So you really only need to focus with what's going on with the y, all right? Again, that's for most of the examples. So this one here is done. Now, looking at the one on the right-hand side, let's see what's going on here. So from 1 to 2, we're adding 1. From 2 to 4, I'm adding 2. Now I'm adding 4. So there's no way that this here is linear, right? It's going to have to be exponential because I'm not adding the same number over and over again. So over here, I'm going to make the exponential side green. Because it's exponential, I'm talking about a growth factor. So we're going to make growth factor green. And again, I want to figure out what am I multiplying by to go down this column, right? So 1 multiplied by 2 gets me to 2. 2 multiplied by 2 gets me to 4. 4 times 2 gets me to 8. So our growth factor here is 2 because we're constantly multiplying by 2. So for each of the examples that you're working on, this is how you should set them up. You're going to color one of these 2 boxes green, one of these 2 boxes green, and then you're also going to give me what the growth factor or the constant rate of change is. Okay, and if this wasn't that clear, you can always pause the video, rewind it, play it again. Okay, so I want you to try the same exact thing on this next page here. You got 4 questions, and then the following page, there are another 4 questions. Same idea, right? After you're done with all of that, if you have some time left over, you're gonna go to the push yourself section where I need you to do 2 things. First, you need to complete the table and then do the same exact thing that we were doing before. So not that much more challenging, but just one added step of finishing off the table that we have here, okay? If you have any questions, just feel free to join the Zoom session, right? The Zoom session password for today is going to be growth, since we're talking about exponential growth. So again, the Zoom password is growth. I will make that actually lowercase g. So I'll zoom in there just so we know it is right there. Growth is what you're going to use, okay? Any questions? Find me there, okay? Good luck, and I will see you soon.